actually, I have this option disabled. I cannot share my screen. So Maria, you should probably enable me to share the screen.
One moment, yes, one moment, I think.
Yep. Thanks. So I have been told that
try now.
40 minutes. It works. Thank you. I have been told that we have 40 minutes. So you should see my screen right now. I hope you all can see my screen. Yeah. So couple of things before we start. I am a PhD student. Well, I am a researcher at the moment and a PhD student and a lecturer at University of Tartu. So that's Tartu, not Tartu. I'm really sorry, that's the way. Also, I do give a talk and I do give a course at UCU. You can see my says proudly on the t-shirt. So I have Autonomous Driving Lab behind my back and UCU on my t-shirt. I give a course about machine learning. I'm really happy to be part of the program, of the master program, because I do think it's probably one of the best in the country, but I wasn't paid to say that. So you haven't heard about it. Yeah, another important thing before we start is that just to make sure that everybody is on the same page, this talk is not about my experience in the autonomous driving lab, which I'm still going to mention one or twice. It's about introduction to self-driving in general. This is basically, you could see the world through my eyes as I learned myself what is self-driving and what people do in self-driving and why people do that kind of things in self-driving. So just not to give you like a false expectations from the talk, this is what my talk will be mostly about. And then at the end of the talk, although Maria said that we have 40 minutes, I'm pretty sure she will be generous enough to give us another 10 to 20 minutes just to talk about my experience in autonomous driving lab, or I can try to finish it earlier so that we still have that time. I will probably check the questions at the end of the talk because it's still tiny bit uncomfortable to move around my browser and come back to slides. So if you don't mind, I'll start. And since I have no way to figure out if you don't mind, then I'll just simply start. So I am myself by training, well, not by training, I'm by training a software engineer, but I actually do work in bioinformatics. So I do analyze biological data using computers and more precisely using machine learning. And so it is now very popular to say artificial intelligence. Well, I actually called it machine learning anyway. So we do use machine learning and computer science to analyze biological data. So how come I started working in self-driving? Well, as one of my ex-students and a good friend of mine just mentioned in Slack to me when we had this discussion, he said that, oh, it's very simple. You just like crazy shit. So I do like crazy shit. And being part of a self-driving project in Tartu, which is a very small but very proud Estonian place, I think it's a very special opportunity. So the car you see here is our Dark Knight, is our Stanley, is our everything, and people inside the car, and the guy with the microphone, and me standing and making this picture are actually part of a so-called Autonomous Driving Lab, which is a project. So Autonomous Driving Lab is a project. It's not a car. And it's run in cooperation between University of Tartu and a company called Bolt. I'm pretty sure you know the company. They operate in Ukraine. So these are taxi service. And at some point, we as a university and them as Bolt came together. We thought that this would be actually nice to see what are the current self-driving capabilities that exist up there and in literature, in science in general, that can be used to make this technology real in Estonia and in Eastern Europe in general. So what are the things that we can adopt as a research and company and make these things happen in Eastern Europe? So we considered ourselves to be part of this kind of initiative. Yeah, as I said, and I wrote two comments, you can find my slides, or at least some part of the slides online. So you can go to SlideShare and you will find this presentation and many other presentations that I have given in the past. And now to set out with the self-driving path of our lecture, of our discussion, imagine yourself somehow in a northern European small country called Estonia. This is where I'm right now, actually. I'm actually in that place right now. And not just anywhere in Estonia, but it's in its capital, in Tallinn. And not just anywhere in Tallinn, but in its beating heart, in the historical center of Tallinn. So Tallinn turned out to have something called Vabaduse Valjak, which is Maidan Nezalezhnosti, basically, but a bit smaller, because everything is a bit smaller in Estonia than in Ukraine. It's like 1.3 million people in there. And you're right here in actually on the road driving somewhere. So imagine yourself that kind of situation. You are behind the wheel, you're driving somewhere in the middle of Tallinn. And where are you driving? So we are driving to a place called Tallinn Song Festival Grounds. And we are driving to the Tallinn Song Festival Grounds because we want to see something called Tallinn Song Festival, which is one of the most probably significant events that can ever happen it's one of the most important holidays in Estonia. It's when people come together and they sing songs, national songs, and they cheer the national values and be happy and all that kind of stuff. Obviously wouldn't be possible these days. I guess you understand why. But this was, I think, last summer. This picture is from the last summer. And there were no obstacles, no viruses in the air. So people did gather. And we are imagining ourselves being part of this movement. So we want to get from Vabaduse Valjak to all these small and big obstacles to all the way down to the Tallinn Song Festival grounds. There is one little caveat though. We are not just driving a regular car, we are driving a very special car. And the special car is because it's a self-driving car. So what does it mean? Well, practically it means that it doesn't see a shit, right? So we can't see anything being a car, right? So you are a car and you don't see stuff. Since you are a car, you don't have this beautiful, magical things we call the eyes, which have been developed throughout evolution, throughout millions of years of evolution. And they apparently built very nicely so that we can, our brains that also built by evolution are able to recognize things and avoid things and plan things and be safe on the roads. So the car doesn't have that. What car has and may be able to use is something that we all know as a GPS, right? So most of the current cars have GPS devices built in. So what our self-driving car can try to do is to drive by GPS. And there are several important problems associated with this idea. We could drive by the GPS. But GPS itself is very unreliable source of information and can be very noisy. I guess some of you may shout out right now somewhere at your homes, shouting that, saying that, hey, but GPS, of course it's raw and very noisy, but you can apply certain techniques to make it stable, somewhat stable. And still, self-driving engineers would say, yep, that's true, but sometimes it still can fail. So since GPS is a system that relies on the propagation of the signal through satellites, so the satellites detect the signal and then they compute the distance to the obstacle to the object, and they figure out the global coordinates. The thing is, the signal may not come through. There are several obstacles that exist that can basically prevent us from having that signal. For example, there are thick clouds or concrete walls of the underground parking lots, right? So things do not really go through the concrete walls. And another problem associated with the GPS is that GPS have very unreliable information about surrounding obstacles. So we may not be able to actually tell apart some certain problems, like having a car in front of us or a person in front of us or a kid in front of us or anybody else. Right? So we have to be context aware. So we need to be sure that we are not going into trouble. Illustrating how driving by GPS can be a misleading thing, there is an example by Taiwan tourists who tried to drive from Brisbane to North Stenbrook's Island. And it led them, basically they were driving by the GPS alone, not really looking probably outside of the window. So they end up being in the sea, basically. So driving by GPS alone sometimes can lead you nowhere, put it mildly. So GPS alone apparently will not save us. It will not be a way to solve all the problems with a self-driving car. So we need a way to somehow look outside of the window, right? So obviously we all know that kind of ways to look outside of the window, and some of the easiest ones are having cameras, right? So there are many ways to look outside of the window. Depends on how do you look outside of the window. It's not just visual information. There are many other information that you can capture. But one of the simplest ways we came up with as humanity, basically cameras. So what happens is that we start to switch on our cameras, and we don't have just one camera, we have multiple cameras. So we have a front view camera, we have back view camera, we have side views cameras. So we have 2 in front and 2 at the back, so that we can see more. Ideally, it should create 360 degrees view so that you can see what happens around you all the time and at any degree. That's one way to look at things, but the problem is the car doesn't see things as we do see things. So we see a tram, or we see some buses ahead of us. But the problem is what car sees is a constant flow of numbers. And it takes a bit of ingenuity and engineering to actually figure out which of these numbers mean what, and how do you interpret, and how do I change my behavior according to this flow of numbers. So just to keep this in mind, that these are not beautiful buses and trees, but these are just raw numbers that the car is supposed to actually analyze and understand. Well, what are the other ways to look outside of the window? Besides having the lights coming into the cameras, we can analyze sounds or sound waves, right? So we could have a front-facing radar. So the radar is sending this waves of sound to the ahead of the vehicle, and it reflects from the obstacles ahead of us and bumps back into the sensor, telling us how fast these obstacles or these objects ahead of us move. So we can actually figure out what's the speed of the bus that is just ahead of us, so that we know if we need to brake, for example. And radar. So I saw that Kuzma had written a question there in the questions app. One of the questions was radar versus LiDAR, and we're going to talk about LiDAR now. But I'm in none of this kind of dichotomy. I'm not having this dichotomy here. We are actually using both of these things. Not so much radar, to be honest. Now more LiDAR, but still, I think all are good. But we are going to get to this discussion in the end of the talk. So besides radar, we have also LiDAR, or light radar. So something that sends out beams of light, or to be precise, laser, that bounces back from the obstacles and gets back to the sensor itself to tell how far the obstacle that it has bounded off is from the obstacle from the car, right? So getting back to our car example, so the LiDAR point clouds would look like this. And each of these points is actually a number telling us how far that thing from the car. So we would be able to reconstruct the reality, the environment around us quite densely. We would definitely see the bus. We would maybe see the traffic sign here. We would probably see there is some obstacle on the left here on this kind of small staircase or something like that. and we wouldn't probably see much on the right side. This is the visualization, how LiDAR works. You can point out, I can point out this blind spot around the car. This blind spot is created because the car itself stops the laser beams from reaching the surface, and that's why there is no signal from immediate radius around the car. You can also see, of course, that some of the circles are more dense ahead of the car, and a little bit less dense and more sparse in the further away. All right, so we talked about LiDAR, we talked about radar, cameras. What else is there in the car? Well, there's something called Inertial Measurement Unit, or IMU. Right? So what is IMU? What does it tell about the car? So IMU measures something, is an acceleration along all the axes. So we can say how fast we move forward or backward. Do we turn left or right? Or do we ascend or we descend with the car? Do we go up the hill or down the hill? Another thing that IMU measures is rotational components. So what is our angle with respect to x-axis? So what is our roll? What is our yaw? And what is our pitch? So these things, including the accelerations along all the axes and rotational components, form something called 6 DOF, which is 6 degrees of freedom. So all the accelerations along the axis and rotational components, they form DOF, or degrees of freedom. And these things turned out to be quite useful and very successful when it comes to pre-processing raw GPS signals. So IMU is usually connected to GPS, and it makes GPS behave well or nicely. And by now, I guess, in our autonomous driving lab, we still heavily rely on GPS and its corrected version using IMU units. So we discussed IMU, LiDAR, radar, and the 360-degree view 6 cameras that we have in our car. And if we combine this all together, this is kind of picture that we get, right? So if you look at every possible data modality that we can collect, we'll have a lot of data that comes into car. But the point is not to collect all these nice and rich representations of their reality, but rather predict one single path. So what we are actually interested in is not all this colorful stuff around the car, but actually getting this a nice and safe path from my current location to my destination, point B, right? Which was the Tallinn Song Festival grounds. So all I'm interested is not to drive over some alive being, and not to get killed by getting into the wall, and not really by actually doing this. I want not to break any other laws that might be important and would cost me money in fines. So this is what I'm interested in. Now that we discussed the sensory stack, right? So this was a sensory stack. It was cameras, radar, LiDAR, IMU, and GPS. We now can talk about the way how self-driving system works, right? On a very abstract basis. So the sensors that I mentioned, they are feeded into the self-driving system that makes sense of the sensory inputs and then sends the commands onwards. These are called actuation commands to control, to steering wheel and braking, accelerating. So it actually basically says to the car, turn right and by this many degrees, and press your brake by this much pressure. Or it could also be that it says that I want you to be in this point and I don't care how exactly you get there. And the car decides itself how exactly to get there. Yeah, so we can now peek inside of this black box, and we will look. So there are several modules. They're called modules that make sense of the sensory inputs and basically transpose or transform these inputs into the decision-making systems, right? So what are the steering wheel angle and braking, accelerating? This specific architecture that I'm going to talk about, for those of you who are connected to the field, I will be describing outerwear design, design proposed by the outerwear framework. This is a very popular freeware software that many self-driving projects use, including ours, to drive their cars. So I'm actually going to describe the outerwear principles. And one of the first modules that I'm going to talk about is called localization. So the truth being said, most of the robots do not really know where they are in the world. So, and that creates, if you think about this, it creates a lot of trouble, because having your car not really knowing where it is in the world makes a lot of problem, in a sense that it could drive through things, or it may not just simply know where to go because it doesn't know where to start, right? So localization is very critical for self-driving, and what can be used besides all the regular sensors is something called HD maps. So we rely on HD maps for localization and most of the time, and I can explain what HD maps actually mean. So in order to explain what HD maps mean, imagine yourself getting in the car and starting the engine. So you start the engine, and in our cars, many other cars, the engine is connected to the electricity battery that starts in as well, and it starts all the sensors and all the measurements. And basically, our car starts to see things around it. So the camera switch on, the lidars or radar switch on, the lidar gets alive, and all that things get actually recorded. So we record all these information that starts to come into our system. And then what happens is that we start to move. We start to move slowly in the environment, and we collect more data from the environment, and we absorb it into the hard drive, right, that we have on the car. So we move along, and we have a circle, let's say, around the place where around our garage, and then we stop the session, and we offload all the data that we have collected so far. We take all the HD drives and we take it to the lab, and we create a database. We create a database of all the information that we have collected from the sensors that we installed in our car, and we call this database HD maps. So this all the information that we had from the previous tours, from the previous sessions, we call HD maps. So these HD maps help us to localize in the environment, and now you can see how this is done. So we have a car. We don't know where we are exactly, but our goal is to find out where we are in the map, right? So what happens is that we get in the car, we start the engine, we start the sensors. So we start with IMU, we switch on the cameras, LiDAR, radar, and everything. And what we now have is some kind of, like a part of the world that we now see through the sensors. And what happens now is that we start to match what we see right now with our sensors to what we have seen before, right? So when we had the tour, what is it that we have seen, and can we match what we see right now with what we have seen? So what it happens, just this is how the way how it looks. We just start to look for a match, right? So we look that this is not exactly the same place. We see that this one doesn't match either. And finally, we find a match, right? So this is where we probably are, because this is how it looks. If we start to match things, this is how it looks. And this is probably where we are. And it turned out that this is what localization is all about, is to localize the vehicle with respect to the map that we have already collected. And this is basically what we have collected. We matched it, all works fine. Now, one problem is that we really need to be very precise with this localization, because well, basically, I think the industry standard is like 10 centimeters error. So you can have it up to 10 centimeters error and be fine. More than that, you can kill somebody. You can have a damage that is not good for your business. All right, so this is how localization works in a very abstract terms. Localization has been a subject of a lot of debates, especially HD maps part of this localization. So you saw that I actually treated on the diagram HD maps as an additional sensor to my system. It's almost like camera, but it's a bit different sensor. So there were a lot of discussions about this. And one of the key problems of HD maps is that HD maps have to be kept up to date all the time, right? So what happens is that sometimes we get cracks on the roads. I guess I'm now talking to Ukrainians, and everybody here in the chat, they probably know what cracks on the roads look like in Ukraine. And then people in the Orange West, they come and they close up the road and nobody can pass it. Besides that, they give like a small pass by, right? So they give additional pass that the cars can use in order to overcome the new obstacle. For the human drivers, there is no problem, obviously. So we have a part of the road that has been closed. We have a additional auxiliary path that drivers take, but we are not a regular car. We are a self-driving car, right? So we have no goddamn clue how to do that. So what we propose, and this is something that is part of the Autonomous Driving Lab project, we propose to utilize the fleet. So the Bolt company has many cars. That's because they're taxi, right? So they drive many cars around the city, and these cars, they move around, and they do nothing useful for us, right? So they do something useful for Bolt, but they don't do something useful for us. So what we propose is that these cars do something useful, not just for Bolt, but for us as well. So what we propose is to assemble regular monocular or stereo cameras to these cars and convince drivers not to freak out and just drive around and record this information and then give it to us. So while these drivers drive around, they see obstacles that they occur on the roads because of the infrastructural changes and things like that. And then they just naturally, by being humans, they're good at these things and they just overcome the problem. And by overcoming the problem, they add additional information to our database of HD maps. And we can update the HD maps based on this new type of input. Of course, that's easier to say than done, but that's what we would be working on, and is trying to actually get these cars update the HD map. Yeah, so that's the idea. And how can you, with the camera, update HD map that has been collected with the LiDAR? Well, we kind of hope for the capacity of the deep neural networks to infer depth from the camera images, because there is a trick that you can infer stereo or depth maps from several monocular camera frames. So this is something that we are relying on, but this is just a research in progress. This is throwing ideas here and there. The next module that I'm going to talk about is a module very familiar to many people who do computer vision. It's called detection module. So again, we are in the full darkness, then we start to switch on things. We switch on LiDAR, we switch on radar, we switch on camera, and we start to see objects around us, right? So the idea is that we need to have some parts of our inputs labeled. So we need to do something called segmentation. We need to say that this part of the input from LiDAR, radar, and the camera belongs to the current lane, right lane. These objects are vehicles. These objects are traffic signs. These objects are pedestrians, and so on and so forth. So we really need to know what are the relevant objects or agents in the environment that are important for us to realize that they exist, right? So these are the important objects. And then these things like localization and detection, they come together into a module called prediction, right? So we predict things. So based on where we are and what objects surround us, we could say that we could drive that path and be safe, right? So this is where we can drive to be safe. These kind of predictions all come together into the decision-making center, where we have a car which drives the road. We now have all the sensors on, and it has an idea where it wants to go. So it kind of tries to proceed, and then it encounters another car moving into the other direction. So what happens is that if the car seems to exhibit normal behavior, then we just follow along the path that we have made for ourselves. As soon as we see that car deviates from its own behavior, we should change our behavior accordingly in order not to, make a trouble, right? So the idea is that we do adjust our behavior according to the behavior of the surrounding agents, and this prediction module is what the decision-making center is all about. So it predicts the behavior of the objects that move around us or can possibly move around us. And this is where the artificial intelligence may come in. The problem is, of course, that currently all that kind of stuff that I have explained so far relies on very simplistic artificial intelligence, of that kind of artificial intelligence. So if the car moves ahead of us, towards us, we better stop or try to move away from the path of that vehicle. Or if you see a tree ahead of us, stop, better stop, right? So very simplistic if then else type of intelligence, which is still kind of artificial intelligence, but not that kind of intelligence that everybody seems to be getting crazy about recently. Right, so this is, we are on the slide 150, and I have managed to explain what modular approach to self-driving looks like. So this is all we have discussed, and all these modules are forming something called modular approach. So modules for modular approach, easy peasy. But then there is another approach that is called end-to-end approach to self-driving. And to explain that approach, I just need one slide. And this is the slide, right? So basically, all of what it takes is just feed all the inputs into this one big deep neural network and pray for this deep neural network to output correct steering commands and braking acceleration. That's pretty much it. There are many problems associated with this approach as well. Probably the most important problem is that it doesn't work. But anyway, there are many companies, and including Tesla, that do have strong faith into this approach. And I want to start with the first company that uses end-to-end. But before, I want to say that for end-to-end, not all the sensors are necessary, and we will see it one by one. I'll show you one by one. For example, there is a company called WAYVE that says that I probably don't hear the sound, but it's not necessary. I'll just switch it off. So this WAYVE company is actually promoting themselves as being needing less mapping and more intelligence. So I propose you to watch that video. It's actually happening in Cambridge, in UK. So he drives a very simplistic car that's meant specifically for this kind of purposes. They actually sell that kind of cars as well. So he starts the engine, and this is what car does purely from the magic of a GPS navigator on the phone and the camera. So there are, I guess there are a few cameras on this car, and it drives through the city. So I take a moment and just check it out, how it drives through the city. So you all know that in UK you have a bit reversed direction of the driving. So it drives through, so this is a fairly dense driving area here. What is in our driving scenarios considered to be harsh is having a left turn. In UK, this is the right turn is considered to be more complicated. So we will see the car performing right turn very soon. I hope I didn't mess it up, because I don't have a driving license, by the way. So this is a car driving purely by itself. You can see that it has safely skipped the bicycle, and now it approaches the intersection. So it has a T intersection here and there. You can see that there are some people moving around. So it does make a right turn here. Yeah, and it doesn't hit the bicycle, right? So that was, I'm not sure how calm was the driver. I wouldn't be calm at all, unless I have done it like 100 times before and I saw that it didn't hit the driver, the bicycle. So it safely drives to the parking lot, and then it the guy switches the car off. So it doesn't know how to park, but it was kind of able to reach the destination. So yeah, that's, oh yeah, this was difficult as well. Right. Yeah, and it has, and you can see how slowly the car drives, like 9 miles or kilometers per hour. I'm not sure. Oh, okay, that's the final destination here. So it switches. It should be switching it off right now. No, not exactly. Okay, now. Yeah, so you can see that it took over the control. All right, so that's how WAYVE. So what the main idea of WAYVE is that they don't use HD maps for driving. They don't use HD maps for driving. Well, in fact, they don't use radar and LiDAR as well, but we're just removing HD maps from here just to give you another contestant. So Tesla was very famous, and not exactly Tesla itself, but Elon Musk was very famous for saying that LiDAR is a crutch. The crutch is what people, when they break their legs, they use to support themselves. And he was basically saying that LiDARs, we don't need LiDARs, because I'm pretty sure none of you shoot lasers out of your eyes when you drive. So why should we then rely on LiDARs when we drive? And that's why Tesla doesn't use LiDARs, but it uses cameras and radar and IMU and GPS. And then there's another guy. So he is the head of the comma.ai person, and they actually deliver smartphones that provide level 2 autonomy, which means that they control speed, and they also can maneuver in very limited circumstances. They can have lane following, so they do have, so they don't control the speed, but they do control the lane following, so they can actually assist you in the lane. And they have just this device that uses camera and the accelerometer and GPS as part of the setup, and that's all they have. So basically, for the end-to-end approach, you need 3 sensors, maybe. The hard part being here is that none of the people have actually convincingly shown that this thing works in all kinds of scenarios that you would need. So if you would compare end-to-end approach to modular approach, you would see that obviously end-to-end approach is so much simpler. You have a deep neural network and you have 3 sensors, and then it all works. While in modular approach, you had to dig into each one of these modules and make sure that it works by the design, and then make sure that they work together, and then make sure that they in sync actually do what has to be done, and then you use a lot of sensors. And end-to-end approach seems very simple, but in fact, of course, it is not very simple. For example, we recently published a paper on arXiv when we reviewed different end-to-end driving approaches, training methods and architectures for the neural networks inside of this black box. And we came to actually propose an architecture that you can see on the screen. So this is an architecture that takes in the camera input and measurements like current, speed, and steering. Road planner, you can use like a Google map here. You don't need a very fancy road planners here. And then all these things go into deep neural networks like CNN and multi-layer perceptrons. You combine the outputs and then you put them into the LSTM because it needs to remember what has been happening in the past. And then you put that through another multi-layer perceptron electron that has multiple heads that you can switch on and switch off. And then you predict the actuation command. So you can predict the steering wheel, accelerator, waypoint following, if you want to follow the waypoints, the cost map, where you say that don't drive this cell, drive to this cell, and so on and so forth. You can also include optionally, if you need to, or if you want to, you can also include HD maps or LiDARs, but this is very optional. So normally this kind of architecture should work without additional crutches that Elon Musk had shrugged off when he was asked. Yeah, so you can see that although promised very simple, end-to-end approach is not very simple. And that's the truth here. And many labs and many companies right now try it, and it seems very promising. And the whole idea of having just one neural network controlling the car seems to be natural, because we have the same approach in our heads, right? So we have neural networks in our brains that control the car, and we seem to do fine. So why can't we have the deep neural network to do that kind of thing? And then provided that deep neural networks actually may do much better job, in a sense, they never drink, they never speed up because they broke up with a girlfriend, or they simply pay attention to things. They don't call their dad to say that they have forgotten this and that at home. They simply drive, and that is a big advantage over humans. So we hope that someday we will see a day when driving a car manually will be a bad ethical choice. So this would be considered to be a daredevil kind of behavior. Just to give you a couple of examples, which could be hard for both of these approaches, and sometimes even for human beings, you can actually see many crazy things on the roads. For example, that kind of shit, right? So how come that guy stolen the stop sign, and how the hell a car is supposed to understand that this is not a stop sign, it has to stop by? Then that kind of things, right? What the hell is that? I mean, just no comments here. And then this thing, right? So it's easy for us as humans to recognize that this is a plastic bag, right? So no problem in driving over that plastic bag. But the car may have a lot of troubles with this, right? So how does the car understand that this is a safe obstacle, and a truck or a tree trunk is not a safe obstacle to drive through? That's all for the initial part. I'm like 45 minutes. I think I can consider this to be a success. So I just wanted to say big thanks to all these people, and there are a lot more people who I have not had enough time to include to the slide. I'm updating the slide because there were more and more people joining the Autonomous Driving Lab. And this is all thanks to them. I have this presentation. I have something to share. And now I'll probably move to my, I will share my, my other screen. So you can see my Google Chrome screen with hundreds of tabs open. Don't be afraid, it happens sometimes. All right, so we have Kuzma's question, which was just voted too. I'm super, I'm not impressed by this. Why don't you guys come in and just upvote and add more questions? So so Kuzma had a question. Your project was R&D or customer based? If customer, when it will come to deployment stage? I must tell you, Kuzma, that the first thought that I had, by the way, I have a quote of you, right? So this is a +1 to my karma. I had no goddamn idea. What is it, the R&D or customer base? I would kind of think that this is R&D. I would say it's more like R than D, but yeah, so both R&D. And I also like to think about this as being also customer based to some extent, because both is somewhat, I would consider them kind of client. So I'm hoping that it will reach the deployment stage at some point or another, but for now it's more R&D than customer based in that sense, I guess. Julia has the second question. Your feeling about the proof of safety for the end-to-end approach. my proof or my feeling is very simple in that sense. I want to see it work, and I want to see it work in a range of different kind of circumstances. And what actually being said here, having said this, I have to tell you that we have been thinking with people here to come up with something that we could use to test end-to-end approach. So what is now lacking, I think, in the field is that kind of a way to verify that it works. So I could actually give you more details about this, but my idea is that it has to show that it works in a range of situations, and this has to be it has to be offline, this kind of testing, and online. So you should be able to first test your agent in the virtual environment, like Carla simulator or something like that, and then also show that it works the same way, very reliably, in the offline circumstances. So that's my take on this, and I would definitely trust it, provided that all that kind of things seem to pass. I wasn't really asked, Kuzma, this question about LiDAR versus radar before. I have been mostly asked about modular versus end-to-end driving approaches. I was asked LiDAR versus camera, but LiDAR and radar, that's something new. I would say if you use LiDAR, why not to use radar? It seems very natural and doesn't cost much. But to be honest, I mean, having said this, I have to say that I haven't heard from the team they actually use radar right now, but we do have it, and we have two of these actually. So I would say that I think LiDAR is more useful if you have it. I mean, it costs like hundreds, it can cost up to like hundreds or dozens of thousands of dollars, but if you have LiDAR or you have a choice, then definitely go for LiDAR. So the car cannot drive on the road. It has not seen before. It's really a big obstacle. In your opinion, when self-driving cars will be more usable? So you know what, Anonymous, nice to meet you. So the thing is, all these end-to-end approach is the promise of the end-to-end approach. So this WAYVE company that I showed you there, I think their motto is that we will be the first to deliver self-driving to hundreds of cities, right? So many companies claim that they will be the first to have a level 5 autonomy, but WAYVE says that we will deliver it first to hundreds of cities. This is a very deep question in a sense, because you can always say that I'm driving very autonomously, but only inside Lviv, for example, or inside Kiev, and I'm not going anywhere else, right? Or the driver should take over when I'm getting out of the city. So I would say that the cars will be quite reliable, and they will be fine inside the very finely defined areas, saying that inside this town I'm kind of cool. Outside of the town I'm not cool at all. So I would say that it should be a big problem. They will be expanding this kind of ODDs, like the operational domains, but it will take time, definitely. Kuzma is notifying us that last Tesla autopilot upgrade added traffic lights recognition. I'm kind of happy about this. Maria, do you want to say something?
Так.
Yep, go ahead.
Але мені потрібно, щоб ти зупинив шарінг. Чи це?
I was just answering questions. So if you don't mind, I'll just maybe answer a couple of more questions. I'll probably skip Kuzma because Kuzma had a lot of questions. So maybe other people want to get their questions answered. And somehow the upvoting doesn't work. Ladies and gentlemen, please take that seriously. It's like super serious business. So do kind of vote for the questions you like so that I can see the questions you like in the top of the list. So Maria, can you give me like 3 minutes? I'll give it to you back in 3 minutes. Would be that fine?
Mm-hmm. Так.
Cool. We are cool here. All right. So I can see Anonymous question here got another upvote. I'm seeing that it's not the same one.
can reinforcement learning solve the problem of self-driving? So the end-to-end driving approach that I told you, it actually relies a lot on reinforcement learning, in a sense that many of these end-to-end approaches, like the WAYVE that you saw, is actually doing reinforcement learning. It's something called mimicking. So it mimics the whoa, that's gotta get out of hand. So I have just 3 minutes, guys. So WAYVE has been able to use so-called mimicking driving. So the person was driving, and then the car was trying to replicate that driving. And when the person saw that the car was doing a mistake, it was switching the car off and getting back on track. And then basically that has helped the car to become better at driving. So this is also reinforcement learning in play. This is a so-called teacher-student model. For HD, Yaroslav is asking, for HD maps, how big the data is per some reference area? The car should store maps for some region, and it occupies a lot of internal storage. It actually does. We have had some back on the envelope calculations, and I think we saw that for an hour or 2 hour session, we'll get something like 1 terabyte of data, about that kind of size. So we just have tons of HD drives on the car. So all this information is stored on the HD drives, and then we just physically unplug the HD drives, and then we plan to carry them back to university and get them transferred information. So that kind of stuff. And I guess last question for today is, are we going to see a hybrid way of driving cars where both machine and person make decisions anytime soon? Seems to be a reasonable compromise. It is a reasonable compromise, and moreover, it's actually this kind of compromise is implemented in many cars, including Tesla. And what I haven't explained here is so-called autonomy levels. And autonomy levels, only level 5 autonomy is the car which you don't have to touch the wheel at all. In all other cars, there are some circumstances in which you may need to grab the wheel and actually make a decision. So I would say that almost all the autonomy levels implement this hybrid way in one way or another way. So unless we kind of make a big leap to the future and all suddenly make autonomous driving level 5, we would be using hybrid approaches one way or another. Yeah. So thank you all for listening. I'm giving back the control to Maria. So I stopped sharing.
Dmytro, I wrote you that we don't have like a restriction. If you want, you can continue answering all questions. Yes.
I guess I'm happy to continue unless I have bored people to hell and they're like, oh my God, just give it back to the Maria and be over with it. But since I have no goddamn way to find out, I'll just go and answer questions and I'll see what happens. So the next question, how you make a fusion of the sensor? Is it done on HW part or the same AI? So I have no idea what's the HW part. I would assume, so there are 2 types of the ways how you can make a fusion, or so the types that I'm kind of aware of. And just to let you know that well, the fusion is when you take the, I guess people can see at least my face, right? So the fusion is when you, maybe even can share my screen, by the way. I just share my slides again, just to, so the fusion, what Alexander refers to is this plus sign here. So the plus sign here is the fusion. So the fusion can be done either before you feed things into the network or after you feed in things to the network. So network predicts something and then you fuse this prediction. I would say that our way is to do the late fusion, so-called late fusion. In the modular approach, I don't think that, I mean, fusion is done in some of the modules, not outside of the modules. So I would say that the fusion is some part of the perception system or something like this. In AI part, this is either late or early fusion. So we would use late fusion in that case. I have seen, okay, so Vitaly's question got upvotes recently. Do you see possible implications of biases like human selection, etc., in self-driving? I do see implications of biases because there were cases when Black people weren't considered to be people by the object detection systems. I see that as a big and huge problem, and we do have to make a lot of effort to mitigate these problems. I see a lot of problems with not having data sets that have snowy streets, like hell none. Like you have California streets all around the place, or you can have Cambridge, which has a mild weather. And then you have almost none of the stuff from places where it has snow, like Russia, Ukraine, or Estonia. So this is one of the things that we set out to to look into, is to fight these biases. Because if your self-driving car that was manufactured in California arrives to Kiev, and then it has a heavy snowfall, and then finally you just basically, you won't go anywhere, right? So you're saying about updating maps. Have you known about this year guy created virtual traffic jams on Google Maps by dragging around 100 phones in a wagon? Yes, I've heard about that. So the maps I mentioned are not the maps that Google Maps. So in the end-to-end driving, they use Google Maps or similar type of service, but I'm not sure they actually use, or they have been using, the traffic information. But even if they had used, I mean, tell me the difference between guy created virtual traffic jams and car not being able to say that this is a guy who created the traffic jam, or a person. I mean, if I would be driving through and I would see that there is a huge traffic jam in my Google Maps, I would say, well, I will take another road, right? How the car is different from that. So I would say that, yeah, there are many ways. And if nobody has written a question about adversarial attacks yet, then let me answer that. There are tons of ways how you can trick the the perception modules by drawing some stickers on the stop sign or whatever, what have you. And then you can do all sorts of awesome things. And but these are more like extra stuff. I mean, obviously we have to fight these things, and but that's a bigger issue. Okay, so there is another question from Kuzma. USA, your pitch role in USSR are Рысканье, Тангаш, and Kren. In case someone know them in that meanings, use the homing missiles head. Okay, so sorry for that. I don't know. Yeah, there is a translation here apparently available. Neural network got advantage because of watchdogs. Even Tesla got 2 processing units for redundancy. Yeah, that's true. So Tesla has several units, GPUs for analyzing the situation. Well, that's true. That's fine. I mean, we want to have happy customers, not like we don't want to have a fair load of work for a customer and a car. So I don't see a trouble here. If we can get our cars safe, we can get our clients safe on the roads. It doesn't matter how many GPUs we put into our cars. What's your opinion on the importance of interpreting the decisions car make? Well, I think it's quite important. And in my presentation, you saw this slide where you had this auxiliary output. And these auxiliary outputs are basically, the idea of this auxiliary output is to understand what car thinks, right? So what is the car, what is it going on in the neural network? Why does these decisions? And one way is to explain this is to make it work through auxiliary tasks. And well, I think it's quite important because humans need some trust. So we need to gain trust. And the trust can be gained by explaining why the car makes this decision and that decision. I think that's the way to go. And I think it's important. What hardware setup I guess it's a question about autonomous driving lab. Well, that's what I told you just now about the sensory stack. It's pretty much our hardware setup. We have a computer, obviously, that assembles all these things together and keeps them all together. We don't have anything fancy, actually, to be honest. So all these things that I described is what we have in the hardware setup. Is current level of self-driving technology able to drive on roads without lanes, like in Ukraine? If so, can you provide more details how it's handled? Yeah, in Ukrainian roads, I think are a special case in all research projects, I think, because of their very unique shapes and all the obstacles that they have. But there are actually lanes are not as important these days. So normally cars learn to predict lanes. So they learn to figure out where the lanes are. Well, I would say that lanes would make things easier, but I think in the case of the absence of lanes, cars learn to figure out where the lanes are. So for that, there are plenty of data sets which have roads without lanes, but these lanes are still have a human annotator having said that this part of the road belongs to your lane, to the car's lane, and this part of the road is not your lane. So cars tend to learn what does it mean to be on my lane and what does it mean to be on somebody else's lane. And these are very important for this kind of situations when you don't really have lane information, if you know what I mean. All right, so I guess, oh, could you briefly explain the 5 levels of autonomy? Yeah, sure. So it's actually 6, like in Python, you start with 0. So 0 level of autonomy is very simple. It's basically like no autonomy at all. You drive on your own, right? So level 1 autonomy is, I think I actually had a presentation for that. Sorry for, I think let me see if I can show it to you. Oh yeah, this one. So here we go. Level 0, no autonomy. Level 1, driving assistance. So you don't have to keep your acceleration. So when you drive, you have to always keep one pedal, right? So you have to keep your legs on the pedal. When you have level 2 autonomy, you don't have to, so there is a lane assistance, right? So you don't have to necessarily turn your wheel every time the lane makes its turn, right? So if there is a lane and a car apparently sees its lane, then it will just follow the lane. Level 3 autonomy is conditional autonomy. It's a limited autonomy when you can drive without, so the car can drive without you on a very limited area. So it's but at the same time, you're requested, you are obliged to take action while if something occurs, and the car manufacturer is not held responsible for this kind of thing. So you are the responsible person. So currently, Tesla is level 3 autonomy, right? So this is Tesla drivers are recommended never to lay off their eyes off the road, but this is what they usually do. There are plenty of pictures of people sleeping in their Teslas, and I don't think it's a beautiful thing, but that's what happens. Tesla seems to be quite reliable for many people, and they even sleep in the car. But you can't, you wouldn't find persons sleeping in the car in the city. This usually happens in the highways. And level 4 autonomy, which is our project, is aiming at level 4. It's more wider areas of full autonomy. So this means that you have less places that you should consider off when you have to take over. But there are some things you have to take over. For example, if it starts to storm or some really unforeseen things happen, then you should be able to take over. But on most of the occasions, you're free to lose the control and not to follow the lane and stuff like that. And finally, full autonomy. It's when you basically can Facebook and sleep in the car without being legally hold responsible for this in any circumstance. All right, so I guess that's pretty much it. I guess I would I would give it back to Maria, I think, so she could. I will stop sharing and I'll give back. So Maria, floor is yours.
Yes, thank you. One moment. Dmytro, could you make me host again? Because I think I can't share my slide.
You give the power all to me, right?
No, I can. I'm sorry. Yes, I see. Yes. Дякую, Дмитру, за виступ. Дякую всім, хто долучився до нас. І перед тим, як завершити, я би хотіла зробити кілька анонсів. Дмитро зараз викладає курс машинного навчання на нашій магістерській програмі науки про дані. І якщо ви цікавитесь цим напрямком, мрієте працювати з даними, аналізувати дані, запрошуємо вас на нашу магістерську програму Data Science. І на цьому сайті ви можете знайти інформацію про нашу програму. Також цього року ми плануємо провести 2 літні школи: Львів Data Science Summer School і Львів Business Analytics Summer School. Запрошуємо всіх охочих провести 2 тижні літа з нами. Школи будуть проходити в липні, і попри карантин ми все-таки очікуємо, що школи відбудуться. Так що, якщо вам цікаво, будь ласка, долучайтеся. І нарешті хочу повідомити, що наступного тижня ми будемо мати вебінар від Олександра Гріса і Михайла Коберника. Вони працюють в компанії Scode Gaming. І Олександр і Михайло розкажуть про застосування методів Data Science до спортивного аналізу, використовуючи вибірку передбачення забитих голів гравцем у футбольній грі. Вебінар так само запланований на наступний четвер на 7 годину. Слідкуйте за нашими подіями у Фейсбуці. Всім дуже дякую. Дякую, Дмитрові, ще раз. Всім гарного вечора.
Дякую вам. Have a nice evening. Bye.